Now, to record the width of the river channel, you need to pull your tape measure from one side of the river to the other that we can see here. You should hold the tape measure right up against the point where the the water meets the riverbank, and then you need to pull it tight. As you can see here, the river is distorting the water, the tape measure, but by pulling it tight, we can then pull it across here. And what I do at this side is I would then find the exact point where the river meets the bank. If I need to go underneath, if the river happens to have undercut the riverbank, then I need to go under that slightly, and then I would record the actual distance, the width of the river in centimeters. So I've got 6 meters and 36, so that would be 636 centimeters is the width of the river. Okay, so just to quickly review that, it's a very simple technique. You've got to make sure it is pulled tight in order, otherwise you get an inaccurate reading, because it's pulled by the river current and it would be longer. If I just let it go, I'll show you what happens. There we go. You can start to see it getting pulled. It also must be perpendicular to the river channel. Now what that means is it's got to be at 90 degrees from the direction of the water. So I'm pulling it tight again. If it's not perpendicular, let's just say it's at a diagonal like I'm doing here, you're not actually giving the true width of the actual channel. Okay, so what's important is it is perpendicular, so you get an accurate width, and that it's pulled tight, so it's not it's not appearing longer. So that is the river width. What I'll now do is show you how to record data on the river depth. Now, to record the depth, rather than just rely on one depth measurement, you're going to need more than one. In this case, we're going to maybe choose 5. And the reason for 5 depths is that the river channel is not the same depth all the way across. So, for example, the point that I'm standing here is deeper than the point over here. And therefore, by recording 5 depth measurements, we can ensure we get a good average depth across the river channel. Now, in order to get 5 depths, we want to make sure they are equally spaced across the width. So what we do is we measure the width, which we know is 630 in this particular location. We divide that by we divide that by 6, which would give us roughly 1 meter and 5 centimeters. And then we go in from the edge 1 meter and 5 centimeters to get our first measurement, which is roughly here. Now I'm going to invite my assistant to come in and demonstrate how you get a depth measurement. So first thing she's going to do is she's going to jump over the tape measure, and she's going to stand downstream from the meter ruler. And the reason that she has to stand downstream rather than upstream, that's upstream up there, is if she was in front of the meter ruler, if she was upstream of it, she would distort the depth measurement and we would have an inaccurate depth reading. So she's going to stand downstream. She is exactly 1/5 of the way across the river channel, and we've calculated that by doing the width divided by 6. And she's now going to lean down and put her finger at the point where the water meets the meter ruler. She's going to lift it up, and you then take the measurement, which I'm just going to zoom in and show you what it would be. Okay, so that was roughly 9 centimeters, or in this case 90 millimeters. So we can do it in centimeters or millimeters. Right, another thing, if she just goes and puts it back in again, another important part of measuring the depth is that the meter ruler has the thin face facing upstream and is streamlined with the flat end across the river. And the reason for that is if I show you what happens, if you twist it and face the flat end up, the water actually pulls up against the meter ruler and you get an inaccurate reading. Whereas if you streamline it with the thin end of the ruler facing upstream, then there's less distortion of your reading and you get a more accurate reading. Now, once she's done the depth there, she then has to move another meter and 5 centimeters along and repeat the process. And she does that 5 times across the river channel. That will allow her to add up those 5 and divide by 5 to get her an accurate depth. One final step, back in the classroom, you take the width of the river here you take the average depth, you multiply those two together, width times depth, and that gives you something known as the cross-sectional area, which is one of the two major pieces of information you need to calculate the discharge. So we've now gathered our width and our depth data. We now need to get our velocity data, which is the final piece of information we need to calculate the discharge.